Okay, there's two ways to find the vertex. You can do that by completing the square or using the vertex formula. And just to make sure everybody's on the same page, this is the review number 15 for the final exam. Alright, so I'm probably just going to do it both ways. So I have to take the 1/5 off of the first two terms. If you guys, I think I might have explained completing square, how to do this earlier in the course. Otherwise, you might have seen it in intermediate algebra. But the general idea is you have to take, the leading coefficient has to be a 1, so whatever here, you have to take it off the first two terms. And the third term, you actually just push it to the side. You just work on the first two terms. So if I take 1/5 off of -4, that's actually negative 20x, and for some people it's easier to go backwards, like 1/5 times -20 is -4. Okay, so this times the first two would give me back the first two, and then the third term you always push it to the side. Now completing the square, the formula for that is 1/2 b quantity squared. B is the coefficient of the linear term, so I'm going to do 1/2 times -20 and square it. Okay, so 1/2 times -20 is -10. -10 squared is 100. So that means that what I need to put here is positive 100 for this to factor into two identical binomials. Okay, now the trick is that you can't just like add 100 in here. You have to counterbalance that. So actually what I added was 1/5 times 100. 1/5 times 100 is actually 20. So what I truly added here was 20. So since I added 20, I have to subtract 20, because 20 minus 20 is 0, which means that I didn't add anything to this equation. So like for instance, if I distributed the 1/5 to everybody, and if I combined like terms, it would give me back this. Alright? This is a way harder technique to do, so if anybody's just getting overwhelmed by this, just ignore it, alright? I'm just trying to help people who want to learn the more advanced techniques. Alright, so now I'm going to factor this. So this factors into x minus 10 quantity squared, and then this combines to be a -5. This 15 minus 20 is -5. Alright, so now this is in vertex form. So in vertex form, the vertex is 10 comma -5. Remember, it's always opposite of the inside, same as the outside. Right? Remember, the vertex form is x minus h quantity squared plus k, where the vertex is hk. Alright, now I'll do it the other way for those of you who want to use the formula. Alright, so we're going to start with negative b over 2a. So b is the coefficient of the linear term, a is the coefficient of the quadratic term. Alright, so again, the coefficient of the linear term is -4. So it's a -4 because there's a negative in the formula, and then there's a negative on the 4. Alright, 2 times a, again, a is the coefficient of the quadratic term. So that would be 1/5. A is 1/5. Alright, now we have to crunch this out. So this is going to end up being 4 over 2/5. So let me write that out the long way. That means that's 4 divided by 2/5. That's what that means. This is 4 divided by 2/5, which would be the same thing as 4 times 5 over 2. I've just, well, actually, some of you may multiply first. So 4 times 5 is 20. 1 times 2 is 2. So this is 10. So that means that the h value of the vertex is 10. Now, if you do it this way, you then have to find the k value. So you have to do f of whatever you just found, which means you have to take the 10 and you have to plug it back into the original. So now I'm going to actually find f of 10. So I'm plugging it into the original. So it's 1/5 times 10 squared minus 4 times 10 plus 15. Okay, so let's just crunch that out. So this is going to be 1/5 times 100 minus 40 plus 15. Sorry, I have to squeeze this a little bit this way. So 1/5 times 100 is 20. So it's 20 minus 40 plus 15. Okay, and then if we keep going, this is 20 minus 40 is negative 20. Negative 20 plus 15 is negative 5. All right, so we get that. So you can see these are the same. So one of them is doing what we would call a complete the square method to find the vertex, and the other one we used a vertex formula to find the vertex. This one is definitely the easier process than this. And again, you only have to use these techniques if the vertex isn't obvious. Like if on the final the problem is given in this form, then you can already see the vertex. So we use either of these techniques when we don't actually have the vertex. All right, there's lots more to do here, so let's keep rolling. All right, so we got the vertex. We need the axis of symmetry and the intercepts. All right, let's work on the intercepts now. All right, y-intercept, that one we know we just let x equal to 0. So we can see here that everything, this is going to 0, this goes 0, so you just left with 15. So that means that when when x is 0, y is 15. So this is your y-intercept. All right, let's go ahead and do the x-intercept. Now there's two ways to do the x-intercept. If you did it this way, it's easiest just to set this equal to 0 and solve it. That's the quickest, easiest way. I will do it both ways so you can see it. So I'll start with the easiest way. Now, technically, most people probably won't do it this way because this is hard to find. Right, so this is y. This is what y equals. So when we do the x-intercept, we're going to set this equal to 0 because we're letting y equal 0. All right, now to solve this, you would first move the 5 over. Then you would get rid of the 1/5 by multiplying both sides by 5 or dividing both sides by 1/5, which gives you the same answer. So 5 times 1/5 is 1. 5 times 5, that looks too much like I'm raising it to 5. It's 25. All right, now you want to get rid of the square root, so we're going to take the square root of both sides. Don't forget the plus or minus. So you're getting x minus 10 equals to plus or minus 5. You move the 10 to the other side. All right, then you crunch this out. So 10 plus 5 is 15. 10 minus 5 is 5. All right, so your x-intercepts are 15, 0, and 5, 0. All right, that's by using the format you previously had. Now, let's say you didn't do that. You don't have that, okay? So if you didn't have that, then it's a longer process. So in that case, you actually have to set this equal to 0. And you're going to try to factor it, or you're going to try to use the quadratic formula. Factoring's easier than the quadratic formula. But you want to get rid of this 1/5. It's not that this is wrong, it's just the format is difficult. And once you set it equal to 0, you can modify the format. So like for instance, I can multiply everybody by 5. Right, so this becomes x squared minus 20x plus 75. Right, so since this factors, the easiest thing to do here is to do the 5 times the 15. And let's see, they both have to be negative. So x equals to 15 and x equals to 5. So that's the easiest way to do it. But if you didn't want to do it that way, then you would go ahead and use the quadratic formula. Okay, so you can see the numbers are going to be a little bit big if you do that. But you could go ahead and crunch that out if that's your preference. Alright, so now we found the vertex, we found the intercepts. Alright, so now the axis of symmetry is when you have the vertex, the axis of symmetry is when x equals to h. So when x equals to h, that's going to be the axis of symmetry. So h is 10, so it's when x is 10. So it's the vertical, it's going to be the vertical line when x is 10. It's going to cut the parabola in half. Alright, let's sketch this guy. Alright, let's sketch this guy. So I have so many notes here because I try to give you lots of examples. Alright, so let's start with the vertex. Before you start, you just want to maybe make some basic thoughts, meaning like this is positive, which means it's face up. This is a 1/5, which means that it's going to be a wide looking parabola. So you may just want to start with like those thoughts. A parabola may or may not have x-intercepts, but it will always have a y-intercept. Alright, so let's put the vertex down. So the vertex is 10, -5. Let me see how much I want to squish this. How big are our numbers? Are our numbers crazy? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 2, 3, 4, 5, 6, 5, 6. Alright, so the vertex is 10, -5. So here's 10. Here's -5. So the vertex is right here at 10, -5. Alright, we said that the x-intercept was 15 and 5. Okay, so one x-intercept is here. 11, 12, 13, 14, 15. And the other one is here. And the y-intercept we said was, oh, that was a 15 also. Okay. 1, 2, 3, 4, 5. This is 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 is here. Alright, so this is the y-intercept. Alright, now the axis of symmetry has to go right through the vertex. So that is right here. That's the line I was talking about before where x is equal to h for the axis of symmetry. So the axis of symmetry is x equals to 10. That's the vertical line that cuts through the center. And I want you guys to try to figure out what the point by symmetry is off the y-intercept. So how you do that is you figure that this guy is 10 units. Every point on the axis of symmetry is 10 units away. And we know that from the vertex. So that means it must have a buddy point that's 10 units away on the other side, because it has to be equidistant or equal in distance on the other side of the axis. So 15, 16, 17, 18, 19, 20. So that would mean that I'd have to walk a total of 20 units to get all the way over here. Oops, sorry, I hope we can still see here. Oh, and this is going to cut out, so I better just wrap it up. Alright, so this is 20, 15, it's over 20 units, same height, and then that's it. I hope the phone won't shut off, but you guys have it if it does. Not the phone, the camera. And then that's it. That is the very final answer. You've got the vertex, you've got the x-intercepts, y-intercept. We call this a point by symmetry, and this is the axis of symmetry. All right, gang, I hope that was helpful. I'll catch you. Bye-bye.